So, welcome back, and today it's all about the noise texture in cycles. And yeah, it's mostly an explanation tutorial and how to get the best performance out of this node. I guess you have experienced that if you're using multiple nodes like 5 or 6 or so, your render gets really slow. And with the wrong, let's call it wrong settings, those settings aren't wrong, they're just slower, right? But with the wrong settings, it gets terrible slow. So I guess you have seen the thumbnail, so let's take a look at that one. And that's a full HD, almost full HD frame here. It's just 800 in height, but otherwise it's a full HD frame. And with the best settings, 49 minutes, and with the worst settings, 81 minutes, right? And it looks almost identical, just a little bit of difference in the noise pattern, not in the surface noise pattern, more in the cycles noise pattern, right? So 32 minutes less, that is quite big, almost a frame. And for an animation that would be really big. Okay, so you know what's up. And let's start with the noise texture. First of all, where do you find this noise texture? Under texture, noise texture, right? Very easy. And we're going to start here and we will end here, right? By the vector output. And we're going to start with the vector input. So that vector input here is for your coordinates, and if you don't connect anything, right, if you leave it blank, then it will use the generated here. So that is useful to know, so you don't have to connect this, right? For example, if one noise node is located here and one here and one here and so on, right, then you don't have to connect this from here, right? If you want to use the generated coordinates. But if you want to use the UVs or the object coordinate, then you have to connect it, right? Like this. That's it for the input of the blue dot here, the mapping or texture coordinates. Next value is the scale value. This one is connected to this blue dot here, to the mapping coordinates. This one acts basically just as the multiplier, right? If you stick your object coordinates in here, or the generated, doesn't matter, whatever you stick in here will be multiplied by 5 in this case. And that's useful to know to avoid certain setups or to create certain setups, right? So let's see, I've created here a setup to recreate this scale effect. So first of all, we're going to render this with objects coordinate and a scale of 5 and the detail of 2, right? So this is the same. Let's render this and you end up with a pattern like this. Okay, let's switch this here. And now we're going to render this one here. And this uses a scale of 1, detail of 2, so detail is the same, but the scale is different, right? Here's 5, there's 1, but we're scaling it, oh, this is wrong, we need the object coordinates. We're scaling this with, how's it called? Mix RGB node, right? Multiply and a factor of 1. So we're scaling it with a value node here. We're just scaling it. And then we're scaling it basically again with a value of 1. So let's render this as well, and what you will notice is this is exactly the same result, right? This is maybe a little slower, or it was actually faster, but it's just a multiplication here. It's not really, it doesn't really affect performance, but it's good to know, right? And for example, if you want to scale it by 25, and if you're leaving it by 5 here, and 5 here, for example, let's imagine you're creating texture, modifier, whatever, and then you scale the object coordinate and then you're scaling it again here. This will end up by 25, by a scale value of 25, right? So let's render this. So then it's smaller, and if we're using this setup here, right, 25 directly, so let's switch to the newer one. That's exactly the same, right? Because your coordinates are just multiplied by 25. So there are more special setups like this here, what is also kind of useful for rocky surface or so, if you want to use stripes. Go away, and let's connect this one here. So objects coordinate, and then we're going to scale them individually, x, y, and z axis. And yes, it will be scaled by the z-axis. Actually, even if here's just 1, right, it will be scaled again by 5. So the real number would be 5, and the real scale number would be 80 and 1, right? So let's render this like this here. Then you get a pattern like this. And Now we're going to plug in the real numbers. So 1 here, and now we have to multiply this by 5. This multiplied by 5 is 1. This is 80. Oops, 80. And this one is 5. And now if you render again, it's the same, right? There's no difference. And yeah, this is useful to know if you want to plug in the real coordinates in your node group or whatever, or if you want to plug in smaller numbers, then you could scale it by 10, for example. Then you have to plug in like 8 or so. It's easier than to plug in 80 or so, right? But if you want to know the real coordinates, stick to 1, right? And avoid numbers like this here, right? 6.22. Let's go back to the original values here. 16 and 1. And yeah, 16 multiplied by 6.322 is quite hard to calculate, but 16 multiplied by 10 is quite easy to calculate, right? The real scale value would be, for the y-axis, would be 160. Okay, that's all. So leave this stuff out, or leave this at 1 or 10 or so. Okay, the next slider is the important slider here, the detailed slider, right? So let's open up a new one, new blend, oops, details. And that's also very simple. It's just a plane, right, at the camera or the graphic view. And yeah, generated coordinates, scale of 5, detail of 0, distortion 0. And I've created a benchmark for this, details, right, 17 different images. And now we're going to look at the images, right? This here is rendered with detail 0, then 1, 2, 3, 7, and so on. Here's 16. And if you look at 0, kind of blurry. 1, also kind of blurry. 2, it's a little crispy. Actually, it's quite crispy. And if you compare 2 and 3, I'm not sure if you can see it through YouTube, but there's a little difference. This here is a little crispier than this here. But between 3 and 4, you can't really see a difference, right? And honestly, between 3 and 16, you also can't see a difference, right? For this, it's just a small image, but yeah, you can't see a difference. But you will see a difference in render time. In this case, 19 seconds versus 32 seconds, right? 13 seconds wasted for the same result, basically. So first of all, the rule of thumb here, right? You should never ever forget that. Keep this value as low as you can keep it, right? If 2 is enough, keep it at 2. If 3 is enough or 4, keep it at 4. I used to crank this up to 16, all the nodes, because sharper is better. Sharper is better, but it's wasted render time, and with multiple nodes it gets quite heavy. So start with 3, right, and then crank it up to 4. If you need a little more crispiness, maybe 5 or 4.5, right? But don't do this here. This is not good for your performance, right? And I also created a multi setup, a very stupid multi setup. Here it is. And yeah, first of all, never ever do something like this here. Those are 4 noise textures with basically the same settings. Not 100% the same, because I wanted different noise textures. This here uses a scale of 5.1, 5.2, 5.3. There's a reason for that, because if you're using such a setup here with 4 nodes, all the same settings, Cycles will optimize that, and it will use only 1 node, right? So it's faster. But if you're using something like this here, this is kind of stupid. Yeah, use only nodes with really different settings. Nobody will notice a difference between 5.2 and 5.3, right? But it will be slower for sure. So then I multiplied it to get something out of here, and I rendered it. Let's take a look at this one. Here's the multi-benchmark. And yeah, not as many images, right? Can I make this a bit bigger? Yeah, it's also a small image, right? But this is here D5, so a details value of 5, 42 seconds. And now with 16, 1 minute and 27 or 28 almost, right? And there's not really a big difference. There's almost no difference in the images, but in the render time, right? That's quite a big difference. So keep it as low as possible, right? This value here, the details value, for every node, for every noise texture, right? For every noise node. Okay, and yeah, there will be a new feature in 2.79, and I benchmarked this as well, and we're going to compare this. So this here is the 2.79 version, and this is the regular version. And as you can see, with the correct settings, you get even more speed up for free, right? It's for free. It will look exactly the same, it's just faster. 42 seconds, no, 24 seconds versus 42 seconds, right? And it will look identical. And if you compare the 16, right, with detailed 16, 40 seconds, so the speed up is not as big, but there's still a speed up. So always use the lowest possible value for the details. And yeah, this is 1 minute and 28. Quite big, right? So this is as fast as with the 5 value, basically, even faster. We're going to talk about this a little later. Okay. Yeah. Most important thing, keep it as low as possible. Remember that. Keep this as low as possible. This is really the key to get the best performance out of it. Next thing is the distortion stuff here. So let's open up the details again. And this one is basically a checkbox, but it's a number field, right? But it acts as or behaves as a checkbox basically, because if you leave it at 0, at really 0, right? Like this 0, not like this 0 here. This is not 0. This here, then it will be off. And if you increase it or decrease it, then it will be on. And it will affect your render a little bit. Where is it? Distortion. So this is with detail 16 and a distortion value of 0, right? 32 seconds. And this is with a distortion value of 1. So if you need distortions, obviously, then you have to turn it up or down. It's 1 second slower in this case here, so it's not really a big deal, but it's a little slower. So really turn it on if you really need it, otherwise leave it at 0. And then there's with distortion 10, right? Same render time, and with distortion 100, same render time, right? So it doesn't matter how big the distortion number is, it's always the same difference, just a different pattern. And it's good for clouds and such, but otherwise leave it at 0 if you don't need it. Okay, that's for the inputs here. Now let's talk about the outputs. And yeah, there will be a new feature in 2.79, as I said. And first of all, let's take a look here. That one was developed by Mylavel. I hope that was correct. But I found the issue basically. And here you can see a few benchmark done by me. Those are my files here, right? My own files. Simple cube is the same as this one here, just with a cube instead of a plane, right? A very simple thing. And Goethe displacement is a head, and Cycles brick displacement is the brick stuff, and so on. The large displacement scene I will show you a little later. But as you can see here, everything is faster, right? This is here plus 0.3%. This is just noise. There's not really a big difference. But as you can see here, minus 32% or 33 almost, right? If you're using the correct output, and in this case it's the factor output or socket. So Goethe displacement minus 16, and here minus 25 and minus 16 again. So big numbers actually. And this one here is the Gooseberry Benchmark, not done by me, but also 4% faster. And this one is not really optimized for that feature, right? It uses a lot of noise textures, but with not correct output, right? For the performance. And Coro is also just a little faster, but it is faster, right? So let's take a look at this. Yeah, first of all, noise texture, 2 outputs. Yellow means color, or 3 values. And factor here, the gray output, means 1 value. And first of all, rule of thumb again. If you stick something in, let's use 2 example nodes here. I see this all the time in different blend files. And here's a color ramp. Right? This here is a gray dot. This is also a gray dot. But people sticking the color in here. It's not wrong, but it's not good for the performance anymore with 2.79 and plus, right? Because those here are 3 numbers or values, R, G, and B in this case, and each dot here got its own noise function to calculate the color in the end. And now it's optimized in 2.79, right? It's optimized for this output here to only use one, because it's just one grayscale output, right? So one noise function instead of three. Or let's put it this way, you're using one noise texture instead of three. And if you look at that, right, that one here must be faster than this. And now it is in 2.79. But you should create your shaders with that in mind, right? If you're using 2.78c, use this output here, not this one. The only reason to use this output here is if you want to use color, right? If you need this funky looking color, then you have to use this color output. Otherwise, stick to this grayscale output here, right? Always. And as you can see here, there's no point in sticking this one here in here, right? Stick this one in here, the gray version, right? It looks a little different, yes, but the noise is noise, right? It's just a different pattern. Because this one here, the color will be converted to a grayscale value, and then it will be used from that on, right? This one is directly basically a grayscale value, just one. And yeah, here also a grayscale. Everything with a grayscale, right? It's also true for the math notes here, right? It's also a grayscale. Don't stick the color input in here. It's not wrong, it's just slower in 2.79 and plus. Okay. So let's take a look at the big scene here. This one here. Oops. What happened here? Okay, here it is. And yeah, this is not the biggest scene ever, but it's quite, yeah, already big, right? With a lot of objects. Okay, it's not 330 is not that many. Anyway, there are a lot of noise textures in it, right? Let's put it this way, there are a lot of noise textures. Every object uses a noise texture, at least one. This one here, those tower things or buildings, right? They are using more noise textures, and actually let's take a look at them. Here's, for example, 2 noise textures, right? And there's a node connected to the detailed slider, a global node, right? 15 in total, to control the stuff here globally, right? So I change it here, and in all of those shaders with this node connected, it will use the same value here, right? And yeah, first of all, I rendered it with 16 and with less than 2.79, and it was quite slow, the scene here, like 4 hours or more. And then how can I optimize this, right? Removing here some math functions, but no, I can't, and it won't really affect performance. And then I tweaked a few settings by accident, the detailed settings, to quite a low number, and then it was faster, really faster. So first thing found, right? And then I checked the noise texture, and I found out that it calculates unnecessary stuff, right? This was fixed by my Lavelle. And now the noise texture with the correct settings is quite fast. It's not terribly slow anymore. So yeah, that's it basically. Again, let's open up the... No, I haven't shown you the render. I'm sorry. Bench is here, right? So this is the original bench, right? With 81 minutes or even more. Rendered with 500 samples, but I rendered it with 2000 samples, and it was quite slow. And so I'm aware of how the difference looks like, right? And there's not really a big difference between those detailed sliding. It just looks like a difference in the noise pattern from cycles, not from the surface itself. So let's switch to the next version, right? Here you can see the render time. And this one was done in 1 hour just by tweaking all the nodes that could be tweaked to 5 instead of 16 details, right? Over 20 minutes less. And if you look at this spot here, you will see a little difference, right? But you know, it looks just like a different noise pattern, different seed, right? In the details, there's not really a big difference, but the time here, 20 minutes less, is quite big. So, and then I rendered it with the fixed version, 2.79 plus, and looks almost the same, or actually looks the same, and it's rendered in 49 minutes, right? I saved it as, no, actually it should look like the same, maybe I used the wrong settings. Anyway, 10 minutes or 11 minutes less, right, for almost the same image quality. So 32 minutes in total, and that's quite big, right? Okay, let's open up the simple noise again. Short conclusion. Okay, this won't affect performance. This one here will, right? Don't crank it up to 16, never ever. If you have to use 16, okay, but I guess you don't have to use that number. Start with 3 or maybe 2, right? Check if that is too blurry or not, and then increase it very slowly, like with 1 or with 0.5 or so. This one here, on or off, a little slower if on, and nothing with 0. And yeah, 99.99999 of all cases use this output here, and if you need color, use this output, right? Or a special case for whatever reason. But this here will give you the best performance, especially if you stick this in this gray value. Yeah? Don't stick the yellow one in the gray one. Doesn't fit. Okay, that's it. Hope that helped a little bit. Thanks for watching, and see you in the next tutorial.